that everyone knows it's SPSS is a powerful data analysis tool. And I'm Kanamalarbal Harikrishnan, and you can call me Kamali. And this is my lady. For any further information, you can contact me. And today we are going to learn these things. These are the learning objectives. First, we are going to learn about importing data from MS Excel to SPSS and how to code the data for SPSS and compute descriptive statistics using SPSS. And we are going to perform normality testing. And then we learn how to perform parametric and non-parametric tests. There are so many parametrics and non-parametric tests. Today we are going to see one sample t-test and paired t-test in parametric test category, and one sample Wilcoxon test and Wilcoxon Signed Rank Test under the non-parametric category. And finally, export data from SPSS to folder we are going to do. We are going to start, shall we start one by one? First, we will start with SPSS. SPS is actually very essential and it is very useful tool to do any data analysis because we can manage, analyze and interpret data, and we can do any type of data, and we can use for, it is useful for writing dissertation, thesis and research papers. There are some pros. At the same times, we have few cons also, challenges also in SPSS, but it is very useful. We can use actually SPSS because we can directly export data from MS Excel, and it is compatible with Windows, and same times we can use for Mac also. And it is a very easiest and reliable tool, and there is no possibility of errors rather than our human errors. And there are few challenges in SPSS. First main thing is there may be a lot of chances for human errors. We can do any wrong analysis. We may interpret the data wrongly. And it is quite expensive. The trial version is only 1 month, and that original software is so expensive. And we can't do any editing in the graphs. If we want to change any values in the graph, we have to create own. We can't use the same graph and the same time we can't edit. So shall we begin SPSS? Shall we begin with the Do you have any SPSS software? Everyone is having SPSS software, I think, trial version at least. No.
No.
Is it possible to download a trial version now? Can you give a few minutes to download so that it will be very useful? You can learn and you can try at the same time.
Okay.
Shall I share the link so that you can download? Is there anyone who wants to try? Can you raise your hand? Or you can send message in chat also. Here is the link for downloading SPSS. You can download a trial version, and after downloading, can you give a thumbs up? I'll wait. We'll give a few minutes for that. Hope everyone is downloading. Is there any problem or is it loading? Hi, Prof. If I share an Excel, can you share it in the group chat? Because only I think admin only can share the documents. Is it possible for you to share, Prof? Hi, Miss Priscilla.
Hi, Miss Kamali.
Is it possible to share the Excel if I share to you? Because here I couldn't find any option to share an Excel document. This is sample data so that everyone can try.
Yeah, you can share to me.
How can I share to you? Because I don't have your WhatsApp number also. How can I share it to you?
Through the chat. Can you try?
Through chat, I can't share. There is no option to share documents. I think only host can share.
Send a screenshot for your screen, please. send a screenshot to Priscilla. She will check and guide you.
Okay. Thank you. Shall we start now? that whoever couldn't download SPSS, as of now, you just follow and observe. Whoever already downloaded that SPSS version, you can try. At the same time, you can listen. Is that okay? Thank you, Ms. Priscilla, for sharing the screen. This is the Excel I shared. We are going to use today to do a calculation. I couldn't share that Excel as a document here. That's why we are sharing that screen. If anyone knows any way to attach a document, can you help me to attach? Miss Yuka. Can you help me to attach?
Miss Kamali,
Yeah.
what shall I do right now?
If you downloaded the trial version of SPSS, you
Actually,
can.
my internet connection is very low right now, so I couldn't download the app. Is there any way that you can show us, like, step by step how to download it
Oh, sure. I'll
by
show.
sharing your
Yeah,
screen?
I'll show. I will share the screen and I'll show you.
And in order to share your content, right, you can actually share the Excel by selecting like sharing option, share
That I
content.
can show, but I couldn't share as an attachment in the chat so that you also can copy paste that Excel to the SPSS. It will be helpful if you have the document as Excel format, so you can import from Excel to SPSS the data.
I see, but I think maybe you can just show us like your slide, I mean your Excel sheet, then maybe we'll do it from here.
Yeah, sure. Okay. First,
All right, thank you.
share my screen to show how to download SPSS?
Yes, please, because I think it's time consuming as well.
Yeah, okay. I will share my
Thank you.
screen and show.
Thank you very much.
Hope everyone can see my screen. If you see IBM SPSS statistics trial, if you are searching, the first tab is showing IBM SPSS free trial. Click on that. Try SPSS. Then you have, I think you got this tab. Then you try SPSS statistics for free. If you click on the try SPSS statistics for free, you will get this window where you have to give your email ID and password and all the record data. As I'm already having an SPSS, if I give my data, it will show an error. So you can try giving your information and try to download it. Meantime, shall I start sharing my screen and show? You can record the screen and you can use it later after you download it. Is it okay, everyone?
Yes.
Okay. After downloading SPSS, first step, we will get an SPSS data, SPSS window. It will look like this. It is an empty like Excel. It is having rows and columns, and there will be two views, data view and variable view. From that, we are now going to import data from Excel. Now I will show how to import data from Excel to SPSS. First go to File, then Import Data, and click on Excel. In that, we will have one tab called Open Data. In that, sorry, my microphone is on mute. I did this. You have to first click on File and then Import Data. Then you have to click on Excel. Here we have some set of data which we can use to import. I'm now using that final data. This is the sample data. Today we are going to use for our calculations. Hope everyone can see my data now.
Yes, Miss, we can view.
Here, if you see, there are in the down at the bottom of the page, we have overview next to the data view and variable view. Data view is that same like Excel. In each row, we are having one sample and each column is representing one variable. For example, first variable is that student roll number, and second column is gender, then third is blood group and student's height and student's weight and approximate distance and math score, like that. If you see in variable view, it is explaining about each variable. Now we have 9 variables and it is representing about each one. First one is student roll number. That is the name of this variable, and there are some type. In this student roll number is numeric and there are only 2 with, and there is no decimal. And if you see, we have to label the variable because in that SPSS name, we can't give any space. So it will be a continuous wordings and that will not be clear. If we label the variable, that label name only will be visible during our calculation. So it is easy to copy paste. If you are copy paste the data and the output or the chat, only this label only will be visible there. So we have to label according to how we want the data should be named. And if you see student's roll number, that is a numeric. So we have to be measure as scale. If you see, there are 3 types of measures here: scale, ordinal, and nominal. Scale is for numeric, and that ordinal and nominal I'll explain later, that we will use for range and for string. So here, if you see, there are 9 variables: student roll number from until weight after sports day. There, in this variable view, you can see all the details about each variable. Now, first, we will start with the data view. I will share my PPT. I hope you all can see my PPT. Here
Yes,
we have our data. And there are 2 views as I explained, data view and variable view. And now first we are going to do descriptive measures. That means mean, median, mode, sum, range, minimum and maximum value, and the standard deviation of our data. This and all comes under the descriptive measures. We will do one by one. For doing this, first we have to go to analyze and descriptive statistics and frequencies. Let me share SPSS and do for you. If you do that, then we have to select which variable we want to analyze and what and all the measures you are going to do: mean, median, mode, and standard deviation. And I click range and minimum and maximum. So let me explain in SPSS now. First, you have to click analyze. Then you have to go to descriptive. Then you have to select frequencies from that. Then you will get a tab which has all our variables. And in that, we have to select which one we want to analyze frequencies. First, we will try with student's height. So you have to select student height and click on this arrow to pull it over here. Now you can see there is student height this side. This variable only we are going to analyze now. Then click on the statistics. You can select which and all measures you have to find. We will select mean, median, mode, sum, standard deviation, minimum, maximum, and range. Then we have to click continue. Then you have to click OK. If you see, if you click on OK, the output will be visible in output. It's in a separate window. I'm opening that. Give me a moment. I hope everyone can see my output window. This will be open automatically, and you can see that statistics of students' height. Mean is 119.87, and before that you can see there are 30. That means we have 30 samples. And in that, the mean height is 119 and median is 120. Excuse me. And mode is 120. And the range is 18, minimum is 110, and maximum is 128, and sum is 3,596. In that, which channel you want to select, you can just, if you double click this, you can copy. It will be open in another window. You can copy paste, or if you want to do any screenshot also you can take, or you can just right click and you can copy this. So you can directly paste this in your Word document which you are using in the analysis. So it will be very helpful. You no need to copy paste, or you no need to type any numbers, because we may do any typo errors because it has so many digits. But in SPSS we can directly copy paste. It will be useful to avoid any errors. Now we find the calculation of mean, median, mode, and all the descriptive data. Now we'll move forward to the next one. Let me share my PPT. Sorry, there is some network issue. I rejoin now. Let me share my screen. Now we want to, this is a sample research question. We are going to analyze and find the answer for this question. Does the average height of X school children is more than the average height of 7-year-old Indian children? Here we have the sample data using, it has some 30 children's average height and few more details. Now we are going to compare their height along with the average height of 7-year-old Indian children. For that, first, we have to find whether you have to use parametric tests or non-parametric tests. To decide whether we need to do parametric or non-parametric, first we need to find whether our data is normally distributed or not normally distributed. To find whether our data is normally or not normally distributed, first we have to do normality testing. If our data is normally distributed, then we can go for parametric tests. And if our data is not normally distributed, you can see we can use non-parametric tests. So we can find whether you have to do parametric or non-parametric by using normality tests. How to do normality tests and for that, what is meant by normality? Can anyone answer what is normality? Anyone knows what is the meaning of normality testing? If you are not comfortable in talking, you can type in chat box also. Yes, normality means equally distribution. Any other answer? Okay, let me explain. Normality means that normality means that data should be normally distributed. That means the data from the least score to the higher score, it should go in an equally distributed manner. That if you see there is a curve, it is looking like a bell curve that from both the sides are equally distributed. Am I right? Data near the mean should be more. That means that middle range of the value has more and there should be from less to high, there should be an equal distribution. Now we are going to find how to find whether our data is normally distributed or not. For that, first we have to go to analyze. From that, you have to go to descriptive. Then you have to go explore. Then you will get this window where you can find which data you want to do normality testing. You have to drag here and then which and all you want. For example, here we ourselves can create stem and leaf plot and histogram, and we can create normality plots with tests, and we have to click continue. Let me explain in SPSS now. Hope you all can see my SPSS data. First, we have to go to analyze. Then you have to go to descriptive statistics, and then you have to go to explore. If you click on the explore, you will get a tab where we have all our variables on left side, and in that we can select which one you want to find to the right side. Now we are going to find for students' height. So click on that and click on that arrow to move it over right side. Then click on the statistics. And if you see that confidence interval is 95, that means our data will be 95% accurate. Now click on the plots and select stem and leaf, histogram, and we need normality plots and with tests. Am I right? So click on it and then select continue and then click on OK. Then our data will be coming to output view. I will open output and I will show. If you see now that test of normality and that student site histogram and the plot diagram and that box and your box plot diagram and everything came in output. I hope everyone can see. And if our sample is more than 150 size, then we have to see the first one, Kolmogorov-Smirnov's test. And if our sample size is less than 150, you have to see the Shafirovic test. Now our sample size is only 30. So we have to see the Shafirovic test. In that, if you see that the significant is 0.119. Am I right? So this is more than 0.05. So this is normally distributed. Am I right? If you see the histogram, you can see it is like a bell. Both the sides are equally distributed. And if you see the cube plot, most of our variables are near to that line. Am I right? So we can find using this or using the histogram. If you see that box plot diagram, here if you see that line is in the middle, that also shows our data is normally distributed. To find that exactly it is normally distributed or not, we can use the Shafirovic test. Here the significant value is 0.119. That is more than 0.05. So we are saying it is normally distributed. So you all know now our data is normally distributed. Then what else we have to do? We have to go for parametric test. Am I right? I hope there is no doubt till now. Is there any doubt? Can I give some time to note it down how to do normality testing? Can I give a few more minutes or shall I repeat it how to do? Okay, then I'll move to the next. Now we have to do parametric test. Am I right? Let me share my screen. What is the meaning of parametric tests? Parametric tests are actually parametric tests are more powerful, and it gives precise conclusion, and we can generalize our conclusion for the normal data. If our variables and data is normally distributed, mostly we need to go for parametric because that is more accurate and that give the generalized answer. So here are some steps to compute parametric tests. First, you have to check the research question, and then you have to formulate the hypothesis. Then you have to set the level of significance. Usually we will select the level of significance is 95% because our generalized data will have 95% accurate results. It may have only 0.05% of errors. Next, we have to do the calculation, basically which test and which related to our question, and then you have to decide whether the result is significant or not based on our calculation. Then you have to do interpretation related to the research question. First, our research question, I hope everyone remembered. Does the average height of X school children is more than average height of 7-year-old Indian children? Is there any difference between the average height of Indian children and this school children? We are going to find now. So for the first average, we are creating null hypothesis. Usually we will create null hypothesis means there is no difference. It will be same or it will be equal. So here we are taking null hypothesis as average height of this X school children is equal to the average height of the 7-year-old Indian child. According to the statistics, the average height of Indian children of 7-year-old is 121 centimeter. So we are going to find now this average 121 centimeter is equal to our sample average, or it is more or less than the average. So we are selecting it both are equal as null, and there is some change. It is more or less than the average as alternate hypothesis. So now we are testing the data with our variables with one constant value. Am I right? We are now comparing our values with one constant. So in that, we are going to use one sample t-test. For doing that one sample t-test, first you have to go to analyze and compare means, and then select one sample t-test. If you select one sample t-test, you will get this window. In that, you can fix the value of the constant. Here, our constant value is the average height. Am I right? That is 121 centimeter. So we are going to compare with 121 centimeter along with our student's height. So we have to select this, and here you have to select student height, and then you have to click OK. Let me explain in SPSS now. Hope you all can see my SPSS data.
Yes.
In that, first you have to click analyze, and then
Miss,
this. Yes, sir.
if I may ask, how do we know the value is 121 for the average height?
It is Very good. First, it is that national statistics value. They have given us 121 centimeter according to the government report.
Okay.
Indian national children, 7-year-old children's average height is 121 according to the government statistics report. So now we are comparing their 121 centimeter with this school children's average height, whether they
I
are
see.
more or they are less.
I see. All right.
Okay, thank you.
Okay, thank you.
So now, first you have to click on Analyze and Descriptive. Sorry, you have to click on Analyze, Compare Means and Proportions, and one sample t-test. If you click on this, you can get student all our variables. Here you can select student's height. Can you able to see my screen?
Yes.
It is taking time to load. Let me do it again. Analyze, compare needs, and one sample t-test. Yeah, now we get the full window. You have to select student's height because now we are going to compare student's height with that constant value of 121 centimeter. Here you have to put 121 centimeter as a test value. And if you see that options, the confidence interval percentage is already 95%. Then you have to click on OK. Here we get our output and output window. Let me share my output window now. Hope you can see my output window. Here, if you see that one sample t-test, me, and all the tables came here. Here, if you see that our sample size is n, that is 30, and mean score is 119 with a standard deviation of 3.8. In that next table, if you see that significance, it is 0.057 and 0.113. Both the values are greater than 0.05. Am I right? That 0.057 and 0.113, both the values are greater than 0.05. Then we have to accept the significant null hypothesis because the p-value is more. Then we have to accept the null hypothesis. Do you all remember what is the null hypothesis? The average height of this school children and the average height of Indian national are equal. Am I right? There is no difference. Both are equal. That was our null hypothesis. Do you all remember that? So here there is no significant difference. Then we are accepting the null hypothesis. Both are same. That average height is equal to the national average. So here the p-value is 0.05. Then we accepted the null hypothesis. So average height of the school children is equal to the average height of the 7-year-old Indian national child. There is no significant difference. That was our conclusion from this one sample t-test. Is there any doubt now regarding this?
It's clear.
Thank you, sir. Shall we move to the next test?
Yes, please.
Thank you. Now we are going to compare two data. Let me share my screen. If you see our data, there was two max score. One is before remedial and after remedial. There was some remedial classes conducted. And we are now going to compare, is there any further improvement before and after the remedial classes? So here we are comparing two values with both are variables, no any constant. We are going to compare two values. So we are going to use paired t-test. In this paired t-test, as usual, we are taking null hypothesis as there is no difference. Here, there is no difference between the math scores before and after remedial. So, naturally, alternate hypothesis is there is a significant difference between math scores before and after remedial. Let me explain how to do this paired t-test in SPSS. For this, first, let me share my SPSS data screen. First, you have to go to analyze and compare means. And in that, you have to select paired sample t-test. If you click on the paired sample t-test, we will get this window open with all our variables on one side. Now we have two variables that we are comparing. So first one is math score before remedial. So put it as variable 1, and math score after remedial, as put it as variable 2. Am I right? Actually, before that, we need to do one thing. I thought anyone will ask. Now, lastly, we compared that student height. Am I right? That we already found it is normally distributed. But if you are going to analyze max score, we didn't check whether it is normally distributed or not. First, we have to do normality test to find whether it is normal or not normally distributed. Then only we can select, we have to do parametric or non-parametric test. Correct? Am I right? So first, we need to do normality testing. How to do normality testing? Do anyone remember?
Analyze.
Yes, very good. Analyze.
Descriptive.
Yes, descriptive.
Descriptive and then
Explore. Very good.
explore.
Now, which one we are going to find? We are going to do math score before
Score.
remedial and math score after remedial. We are going to test these two variables are normally distributed or not. So first you are taking these two and check the plots, and it is already selected. So click on continue and click OK. The output is coming in output view. Let me open my output window. Can you able to see my output window? In that, if you see our samples are less than 30, so you need to check Shapiro-Wilk. Am I right? In that Shapiro-Wilk, both that significance before remedial and after remedial are 0.508 and 0.718. Both are more than 0.05. Am I right? So these are whether these are normally distributed or not. Here, both are more than 0.05, so these are normally distributed. If you see the histogram, you can find a bell curve. And if you see that plot diagram, all the values are nearing to that line. If you see the box plot, it is almost equal. Am I right? And after remedial also, if you see that histogram can be like a bell, and both are near to the middle. Am I right? So here again, this data are normally distributed. So we need to do parametric test. To compare two variables and do parametric test, we have to do paired t-test. So now we are going to do paired t-test. Let me share my SPSS window. My data. Now we have to find analyze and compare means, and you have to select paired sample t-test. In that, we already selected math score before remedial and math score after remedial. Now we are going to compare these two. Am I right? So now click on OK. Here the output came. Here the math score before remedial mean of it is 22 and after the remedial mean is 25. So we can find there is a significant difference, but we need some value. Am I right? If you see in this paired sample correlation that both the values are less than 0.01, that is less than 0.05. Am I right? So we are rejecting our null hypothesis and we are selecting alternate hypothesis. What is the null hypothesis we have selected? There is no difference in the math score before and after remedial. That is rejected. That means our null hypothesis is rejected. So we are selecting our alternate hypothesis. What is our alternate hypothesis? There is a significant difference between math score before and after remedial. Am I right? Is there any doubt? Hope everyone clear how to perform paired t-test. Is there any doubt? Shall we go to another one? Shall we move to the next, or shall I give some break? Okay, let me move to the next one. Let me share my SPSS. Now, as until so far, we did comparison of height and we compared the scores, math scores before and after remedial. Now we are going to compare the weight. Is there any significant difference between the child's weight between the school children and the weight of the Indian national child of 7-year-old? According to the statistics report, the weight of 7-year-old would be around 20 kg. So now we are going to compare the weight of these school children with a 20 kg. So we are comparing one variable along with the one constant. Am I right? One value, constant value of 20 kg. For that, first we need to find which test you need to use. Is there anyone? What test we need to do? First step, we need to do the normality testing. Am I right? First, let me move to the normality testing. Hope everyone can see my SPSS data now. First, you have to go to Analyze. and descriptive and explore. Now we are not going to compare math score, so take it back and we are going to compare students' weight. So take it to the dependent list. And we have two weights. One is before and another one is after sports day. We will take both and same time we can do normality testing. So first let me check. I'll share my output window so that everyone can see the output. Sorry, it is loading. I think now you can all see me. See the data output view. If you see, as our data is less than 30, you all already know which test you have to see. You have to see that Shapiro-Wilk. Am I right? If you see in that Shapiro-Wilk, that student weight, the first student weight is 0.001 and the another one after sports day is also less than 0.01. So these two, these values are not greater than 0.05. So these two are not normally distributed. Am I right? These both the values 0.001 is less than 0.005. So we are saying these two are not normally distributed. If you see the histogram, you can notice clearly there is no bell curve and the 20 is more where the 32 is very less. If you see that Q plot also near to the line, there is not much values. The values are segregated everywhere. And if you see in this box plot, that middle line is at the bottom. If you see in that second weight after sports day also nearly same, there are more weights on the least value and then it is decreasing slowly. So in that we can conclude these two values of weight are not normally distributed. So we have to find in the tests which are suitable for not normally distributed. If the data is not normally distributed, what we need to do? Is there any answer? We have to move forward to the non-parametric test. Am I right? Let me show. Now you all know if it is normally distributed, you have to do what test. But if it is non-parametric, you need to know what is the equivalent test. Am I right? Here I am sharing the tests which are nearly equal for non-parametric. If the value is normally distributed, we have to use parametric test. And if it is not normally distributed, we are going to use non-parametric. So rather than using one sample t-test, here you have to use one sample Wilcoxon test. And instead of using pair t-test, which we are while we are comparing two variables, we will use pair t-test. Am I right? We compared the max scores. Like that, comparing two variables, you have to use here Wilcoxon Signed Rank Test. For independent tests, you have to test Mann-Whitney U-test, and instead of one-way ANOVA, you have to use Kruskal-Wallis one-way ANOVA. So now we are going to compare the weight of the students of that school along with the Indian national average. Am I right? We are going to compare one sample and one constant. So here we have to use one sample Wilcoxon test. Let me explain how to do one sample Wilcoxon test using SPSS now. I'll share my SPSS window now. Hope everyone can see my screen. In that, first you have to go to Analyze and you have to select non-parametric test. If it is parametric test and we are going to do t-test, it was here. It is here we did actually. Am I right? Compare means and proportion. In that we have all paired, one sample independent paired, one way ANOVA and everything. All parametric tests was here. Now we are going to do non-parametric test. So here that one sample test is there. You have to click on this. Then you can get all the data, all the variables here. In that we are going to do students weight and you have to run. The data came in, the output came in my output window. Let me share my output. Hope everyone can see my value. We are doing now non-parametric test. I hope you all can see here itself they given already. The value is less than 0.01 in that significant column and the decision also shown reject the null hypothesis. What is our null hypothesis? There is no significant difference between the average height weight of that school children and the Indian national average height. So we are rejecting that null hypothesis. What it means? We are going to accept the alternate hypothesis. Am I right? What is our alternate hypothesis? Our alternate hypothesis is there is a significant difference. Sorry, there is some. There is a significant difference between the school children's weight and the weight, average weight of the Indian nationals' weight. If you see in this curve, hope everyone can see my screen. If you see in this graph, we can find that clearly that in that middle, there are very few and it is segregated everywhere. So we can find from this also that there is a significant difference. And we are accepting the alternate hypothesis. Is there any doubt? This is the way you have to do. Is there any doubt? Shall I move to the next test? Okay. Now we are going to compare the weight of the ex-school children before and after the sports day session. There was a sports day practice and they are comparing the results of their school children weight before the start of the practice and at the end of the session. So there is a research question. Is there any difference in weight before and after the sports day practice session? For that, we are selecting null hypothesis as usual. There is no significant difference in the weight before and after the session. And the alternate hypothesis was there is a significant difference in the weight. That means there may be less or more weight before and after. So now we are going to compare two variables. For comparing two variables, if it is parametric, we will use par t-test. Here, we are going to do Wilcoxon Signed Rank Test. Am I right? So, let me explain how to do Wilcoxon Signed Rank Test using SPSS now. Let me share my screen of SPSS. First, you have to go to Analyze. And then you have to go to non-parametric. And then you have to go to legacy dialogues. And here we have two samples. Am I right? So we have to select two related samples. One is students' weight and another one is after the sports day. Here that is students' weight before the sports day and the second one is after the sports day. And the test already selected, that is Wilcoxon test. Now click OK. The output will come in output window. Let me open my output. Hope everyone can see my output window. If you see that, sorry, it is loading here. That's in the Wilcoxon Signed Rank Test, that significant value is 0.008. That is less than 0.05. Am I right? So that value P significant P is less than 0.05. So we need to reject the null hypothesis. That means we are rejecting that there is no significant difference. And so we are accepting there is a significant difference among the children's weight. Am I right? Let me explain now in PPT once again. In that, there is no significant difference in the weight of the children before and after the sports day. It's our null hypothesis. As our p-value is less than 0.05, we are rejecting the null hypothesis and the alternate hypothesis is accepted. That means there is a significant difference in the weight of the children before and after the sports day. So this is the end of our last session, last test. And hope everyone understand. Is there any doubt? Or if you want to repeat any test, Yes, Miss Priscilla. Miss Priscilla?
Sorry, Doctor. Accidentally.
Oh, okay. If there is no doubt, shall we do one Kahoot session? Are you all ready to join in that Kahoot so that we can refresh our knowledge and get clear idea whether we understood clearly? If anyone is willing, can you join using this game pin? Anyone is willing?
Do we need to download this?
No, you can just,
Scan.
yeah, you can just scan,
Okay.
or you can go to kahoot.it and use this game pin using your phone. You can join with nickname.
Okay, will do.
Okay, thank you. One participant came. Anyone else want to join? Yeah, one more participant. Anyone is trying to join? Shall we wait or we can start? If anyone is trying to join, please raise your hand. Shall we start?
Yes, Miss.
Okay, we'll join now. We'll start now. What is the expansion of SPSS? Select the correct answer. You have 30 more seconds. Very good. There is one correct and one wrong answer, I think. The correct answer is statistical package for the social sciences. Shall we go to the next one? Very good, Herbert. Next, question 2. SPSS helps only in data analysis. True or false? We got one answer already. And two answers. Again, both are answered differently, one true and one false. Actually, false is the correct answer. SPSS not only helps in data analysis, this you can use for many other purposes like creating graphs and grouping and regrouping and commuting all the data. And now this is scoreboard. Both have one correct answer and press at the top. Let me move to the third one. Pick out one descriptive statistics value. Which is descriptive statistics in this? T value or P value, F value or median? I think both are thinking. One answer came. Median is the correct answer. There is a change. Herbert now answer correctly, I think. He's in the scope of us. Next question. True or false? The scale of measurement for gender is interval. Gender is interval scale. It has any range of values. You have to select true or false. One answer came. Waiting for the second answer. Again, one true and one false. Actually, false is the correct answer. Gender is a nominal scale because there has only two options. Now again the scoreboard, Herbert is at the top. Very good. Now let me move to the next one. Which of the following is a normality test for sample greater than 150? If it is more than 150, you have to select one test, and if it is less than 150, we used another test. Which one we have to use for more than 150? Independent, Patch, Shafirovic, or Kolmogorov? One answer. And two answer. Again, two different answer. Actually, Kolmogorov is the correct answer. Now again change. Press is at the top now. Very good. Let me move to the next one. Identify the suitable test to compare IQ of 100 students with the national average. The p-value for Shafirovic is 0.8. We are comparing with the national average. Which test we need to use? One answer already and 10 more seconds. One sample t-test. One answer. Again, press at the top. Next one. A researcher identifying difference in weight before and after and diet plan. Predict the suitable test. Before and after. One answer already. And this time Herbert. Moving to the next question. Identify the equivalent non-parametric test for independent t-test. It is already in the chat box. One answer. Then more seconds. It's Man Whitney U test. We move to the next one. True or false? SPSS data can be saved in the MS Word document. We can save it or not. Again, one answer. Actually, it is true. We can save. Herbert at the top now. 10th, last question. Analyzing data using SPSS is easy. True or false? One answer. Fourth answer. True. It is correct. Very good. I think everyone enjoyed this quiz. Is there any more doubt? Do you want to ask any doubt? I hope everyone are clear with this test.